and welcome back to the very last workshop that we have. Unfortunately, today's will be very dense because, my goal was to get this workshop series done before the game jam, which is tomorrow. And so I want to teach a lot of what I consider kind of basics, more like essentials for game development in terms of all the different components that you need for games to be able to comfortably make something for the game jam. And so today's will be pretty dense as we have some things that we need to kind of clean up from the previous workshops that we haven't finished, and then a lot of stuff about our events and audios and those types of things. So this is what we'll be doing for today. Lots of different sections. So the first one will be cleanup, as in we have some small things that we didn't do last workshop that we will finish up. And of course, last week's workshop, I was hoping to cover menus and UI, and I didn't do that, so we'll cover that today. We'll go through pretty quick, but it shouldn't be too terrible. So menus, and then the in-game UI. Then the kind of weird, a little bit of advanced programming, but not too bad, and essential to games is your events, a simple game manager, and then audio, okay? So, first we have our cleanup. So essentially we have the other timer that we didn't do last time, which is when the player takes damage. And then we also have our health pickup. So right now we only have our power-up pickup, so we're just gonna quickly implement the other one, which again, if you remember how we did the pickup last time, shouldn't be too bad. So, what we want for this cleanup is, of course, the other timer and the health pickup. So the other timer is essentially, it activates when the player takes damage. And then also, okay. And then while the timer is active, the player cannot take any other damage. And also to indicate that to the player that they can't take damage, we're gonna kind of gray out our player sprite. So essentially what we're gonna actually do is take the sprite component and set the color to be gray. Because if you remember, the white color is kind of like whatever the sprite normally looks like. And then we have our health pickup, which is just like our other pickup, but all we do is that when the player collides with that one, we just increase our health by 1 instead of increasing our speed of the player. So, for this timer, that's kind of what it's gonna look like on the right when our player is grayed out. But like the other timer, we have a bunch of variables like the time of our the length of our timer, if the timer is active, the time stamp for when the timer is done, and for this one specifically, we'll have a sprite renderer field. So again, to change the color, we want to have a reference to the sprite renderer. So I'll be kind of moving this workshop a lot with the editor here, but essentially we have we want to get the sprite render in our start, like how we do all of our other components. And then we'll have a new function similar to the other one, which is called invul timer check. So I call this timer the invulnerability timer. And then obviously when the timer is active, the color is set to gray. And then when it's not active, we'll set it back to white, which is our default. So I'm going to jump into the editor here. This is what we have last time. The scripts here don't have all the comments, but on the GitHub, they do have all the additional comments explaining what each line specifically does. But this is based on our last workshop. So so this is all gonna be inside of our, why does it do that? Inside of our player script. So I'm gonna go to my scripts, player, open that up. There we go. Okay. So let's scroll all the way up here. So this is kind of our the fields that we had last time. Again, these are not commented or organized like last time. Why can't I? Doing this. Do you know why, Pavel, do you know why I can't edit the script?
What do you mean?
Like, I'm typing and it's not doing anything.
I would say reset Visual
Restart it?
Studio.
Okay. That's not that's not good. If anything, I'll open it in a different program, which won't have the autofill, but that way at least we'll do it. No. Oh, there we go. Okay. Whew. I was gonna be really scared. So, back at our slideshow here. So let's just put those there. So we have our float. And I'm just gonna follow the naming convention that I had last time. So invol timer length, I think I had this one just set to 1 second. Is invol, so if we are invulnerable by default, we're not. And then invol end time, which I'm gonna set to 0 seconds. So, and the other one we have is our sprite renderer. I'm gonna call it sprite rend. So in our start, we, again, like all our other components, we save the reference here. So game object get component, and the type is gonna be our sprite renderer. So we have this reference now. Then we activate this timer in our trigger here. So when we take damage, so here, activate invulnerability timer. So this will just, I believe, just check this. I actually think, because here I check if the players died, so we don't, I guess it doesn't matter, but I guess I don't want it to, well, it doesn't matter, because if the players died, then they're destroyed, so this actually won't matter. So I'll have a function called private, again, it's private because we don't want other scripts to access it. Voided doesn't do anything. And I'll call it with a similar pattern like our other one. And it will be very similar to this one, right? So if we're not invulnerable, then now we are, right? Oh, I'm not typing well. Our end time, okay, is going to be the current time plus our length. And then here is where we set, instead of the speed, the color of our sprite. And we can do different things like RGB and stuff like that, or maybe a hex code, you can look it up. But there are some simpler ones. If you just do color dot, there's like really basic ones. So I'm gonna do gray because it's built in, which is amazing. And then the other thing is, if our timer is already active, then I'm gonna check if my current time, which I access with time.time, is like past our end time. So greater than means like if it's past this timer. Then we're gonna change our color back to color.white. And then now we are not invulnerable, right? So I'll call this function here, right? Where we check, essentially we set it up when we collide with our damage, but we also want to check in our update if this is done or not. So if we are invulnerable, then we're gonna check if the timer is done, right? So we can check here. We created a new function, we got our sprite render in the start, and we have this with gray and white. So let's run our game and see if that works, if that happens. Okay, So we have our animations here, like last time. We have our sprite. Let's make this bigger. And then look, when I take damage, oh, here, I forgot this one thing. We were still taking damage even though our sprite was changed. So we want to check here when we collide with our enemy with the damage if we're not invulnerable, right? Because if we're already invulnerable, then we take damage. If we are invulnerable, then we don't do anything. So if in is invul is false, or again, you could also use the exclamation point, then we're gonna take damage. And actually we're gonna put this here then, because we're only gonna activate the timer or check for the timer when we take damage. And this health check, you could place it inside if you want or not. But essentially, if we collide with damage and we are invulnerable, sorry, if we're not invulnerable, then we're gonna actually decrease our health. So let's go and check that again. So now, our invulnerability is pretty short. So I'm just gonna make it longer to showcase to you that we don't take damage again while we're invulnerable. So here I'm colliding. You can see down here my health. So when I'm grayed out, even though I'm colliding with the enemy, I don't take any damage, which is what we want. Awesome. So again, it's pretty fast-paced this time. So I'll go around more closer to the end, hopefully after. I don't want to keep you guys too late. So it's pretty dense today. The other thing that we want for our cleanup is our health pickup. It's just gonna be like the other pickup. This time it's gonna have a different tag. And then inside of this, when we collide with it, we just do something different for our check for when we collide with it, right? So again, back in our player script, actually let's make this object first. So because we have our prefab with I guess we can make a prefab with our pickup power up, but let's make one with our health. So we have pickup health, which with our sprite options here, again, we have 32 pixels per unit, no filter, and no compression. So the sprite is already good. I'm just gonna rename my object to have uppercase letters. It's gonna have a collider, and it's gonna be just a trigger, but it's not gonna have a rigid body because we don't want it to have physics. And then we're gonna give it a tag, because see we have this pickup power tag. We're gonna create a pickup health tag. And then give that to our pickup. Okay, so we have a collider, we have a tag called pickup health, and the object is named pickup health. I'll drag it into our prefabs here so that it's a prefab, and I could move it around maybe after this first enemy. So that's the actual object. And all we have to do is inside of our, let's see, on trigger enter 2D. So for example, here we have on pickup power, right? So here we're gonna check if the game object that we're colliding with has a tag of pickup health. Oops, lots of typos today. Then what do we do if we want to increase our health based on this?
Increase your health.
And also destroy the object, right? So like this one. And then health increased, we could do this shorthand. We could also do an even more shorthand, which is this plus plus operator, which increments your health. So these do the same thing. I'll just leave both of them. So if you are learning programming, these are some common little techniques. And now, when we play test the game, again, we only have our health showing up in this place down here. So our health is 4, and our health went back down to 4 actually. So you can add this health here. to showcase that the health is indeed getting bigger. So, there we go. So we take damage, our health is 4, and then our health went up to 5. So it does what we want. This also with the pickup, this pickup allows for our health to go above our maximum health or our starting health. So our starting health, I believe, is 5. I believe I said that to be 5, yes. And then obviously when we heal, we add that. So by design, I want my player to have extra health as kind of like a bonus or a shield. But if you don't want that to happen, then you just add a little if statement checking if your health is already at its maximum health. Okay, there's some cleanup just to have that in our project. Now let's get to some cool new stuff with menus, which again is hopefully should be pretty simple. So a main menu. What do we want with our main menu? We want to have a screen that the game begins with. It'll just have 2 buttons, a start game button and a quit button. And then I want them to kind of change color when I hover over them and when I actually click on them. There's also an option to change the sprites if you have custom sprites for that, which I can tell you how to do if you find some sort of sprites online or you make them yourself. But for the purposes of the workshop, we'll just do the color change. So I'll do this with you guys right now, but essentially we're just gonna create a new scene and I'll go over the elements for UI, which Unity uses a canvas, and then you put UI elements on that canvas. And then we will just rename some things and add some functionality afterwards. But first we're gonna build it out and then we're gonna code it in a way, right? So, back in our editor, we have a scenes folder already. We have this scene that we've been working with called sample scene. Now that we're actually talking about scenes, I'm just gonna rename it to level, or you can call it game, or you can call it level 1 because hopefully after this workshop you can create multiple levels easily. But in here, I'm gonna create a new scene. So create scene, and I'm gonna call it main menu. Okay, and you can just double click on it to open it up. So here's our main menu. So what do we want? So we wanna have 2 buttons. So in our hierarchy, which is here, we wanna create a button. So what you can do is, also there's this plus button you can use. There's a tab UI, and there's these common UI elements, and we're gonna have button. There's a Word Text Mesh Pro, which essentially just is a plugin that comes with your 2D template, and it just gives you more options to customize your UI. So I'm gonna click button. This thing will pop up. I'll be like, sure, import it, that's fine. And I'll close it. And we see in our hierarchy here, it creates an event system and a canvas by default for you. It creates it automatically. I will cover this in the next section when we talk about more about UI, but what we wanna focus on right now is this button that was made for us. So I'm gonna call this button game, or start game. And I leave button at the start just to know what it is. But you can double click on canvas to get this view of like everything that's in your view. And then you can actually open up and see that your button has text. So I'm gonna call it text start game. And this is the text that's on your button. So I'm actually gonna see it says button right here. I'm gonna put start game. And it updates it for me, which is awesome. In your actual button though, you'll see some different, properties here that look different from a sprite, of course. But essentially here we have our button component, and here is where you can see it says transition. Right now it's defaulted to color tint, which is what we'll be using. But if you could also do sprite swap, and so obviously it's kind of like you populate this with sprites that you have, if you have your own sprites. I'm gonna be using color tint. So I'm gonna have it be, I suppose, I don't know, I'm gonna make it like slightly green. I'm gonna make it green. And then when it's highlighted, I'm gonna make it like a lighter green. And then when it's pressed, I'm gonna make it, I don't know, a dark green. Yeah, so I'm just gonna choose some color. I guess green, because you know, green means go. And then the other thing is we want this to be positioned kind of in the center of our screen, right? So you see this cool, instead of a transform, it has a rect transform. So I'm gonna anchor it to the middle. And then see here, so this anchor is already in the middle, but then we have a position with regards to the anchor, okay? So anchors are useful, these will only apply to your UI, but it's kind of like you tell it where you want stuff to be located, right? So this is with the position relative to the anchor. So if I change the anchor, you see that the position changes, right? And this little thing, cross, indicates where the anchor's at. So I want it to be in the center, so I'm just gonna put 0, 0, because it's relative to my anchor. And then I want it maybe slightly above the center so that we have 2 buttons. So I'm gonna make the position, Y position, maybe like 30. Sure, that looks good, right? Let's see. Yeah. The one thing, since we're setting things up, in your canvas you want to change pixels per unit to 32, which shouldn't hopefully change much because our sprites are 32 pixels per unit. So we're going to just update that to be sure. I'm actually going to also rename my canvas to be, I'm going to call it UI because that makes more sense to me than the word canvas, but it's up to you. So we create our start game button, which is a child of UI, right? And then we have this text, which is a child of the button. So under UI, I'm gonna right click on it and create a new button. I'm gonna call it button quit, button quit. And I'll call this text quit. And the text will be, well, quit. Makes sense. Then for this, I'm also going to anchor it in the center. In this case, the position is going to be -30 to kind of be symmetrical, to mirror the top button. And I'm going to make the colors similar, but red. So to test out this, you can actually play it, and it won't do anything, but you'll see that when I hover over it, it actually does something, right? The color changes based on where my mouse is, which is great. So that's what we did here. This text is just writing out what I just did. So it's more for if you want to look at the slides later after this. Also, there's a link here talking about the canvas more if you are more interested in details about that. But now that we have these buttons, we want to actually make them do something. So we're going to do that by having a script that kind of handles this, and then the buttons can actually refer to functions within that script. So we're going to create a new script, create C# script. I'm going to call it main menu and open it up. And then for this one, it's an interesting script where we actually won't have any of this, because it's not gonna do anything on its own. It's only just gonna have functions that the buttons will reference. So I'm gonna make a function called onStartMenu, which the button start menu will reference and use, and then on quit. Not on application quit, just on quit. Okay. And one thing you want to make sure is that these are public functions, because again, we actually want the buttons to see these functions outside of this script. So these two are both public, but I'm just gonna save this for now. And we're gonna link the buttons to this. So how we do that is if you click on the button, this button component has an on-click kind of box down here that says list is empty. And essentially, when we click it, we're gonna tell it what to do. So, let's see. I think I have to attach the. Actually, we're gonna real quick attach the main menu to the, I guess maybe the UI. It doesn't really matter where you attach it. You want to attach your script to something in the scene. So I attached it to my UI. So it's gonna be down here. Because what we can do is down here, is drag this UI over here. So it's kind of like reference this UI object, and then we can access components in that object. So we're gonna reference the main menu script, and then we're gonna reference on start menu. So this is the start menu button. Sorry, start game menu. Did I say start menu? Oops. Start game. Because here we can main menu script on start game. So now what happens is when we click the button, it's going to take the main menu script that's attached to my UI object and call the onStartGame function. Okay? And then we do the same here. Main menu on quit. Awesome. So let's check here. We created a script and we created these two functions. Awesome. So now we actually want to do things with these functions. So on start game, I want to move to the scene called level, and on quit, I want to quit my application. So here in the slides, I have, you can easily quit the application with application.quit. So we're going to just do that real quick. Awesome, that's simple. The on start game is a little bit more complex, but not too terrible. Because I guess to go over, I'm going to jump here real quick. It uses the scene manager library because we want to, of course, manage our scenes. We want to move to the next scene. We want to load a scene. So to see our scenes, I'm actually going to go to File, Build Settings, so the build settings that we talked about last time. And here at the top, we have scenes in build. So right now we just have the level scene in our build, but we want to click this Add Open Scenes, and now we have our main menu scene added to the build. So when we build our game, the scene is going to be included. We actually probably want the menu to be above the level because it's going to be the order in which the player accesses these levels, right? So we're going to first load the main menu and then the level, right? Essentially, you can see here, this is the name of the scene, and then we have this index of the scene, again, the order of it. So our main menu has an index of 0, our level has an index of 1. And so, inside of start game, we want to go to that scene, right? So to do that, we actually need to kind of import a new library, which is using Unity Engine.scene management. Because now, here, we can do scene manager, which is included in the library, load scene, and there's different ways you could do this. You can load it by the name or by the index. I'm going to load it by the index, but I'm going to make it kind of versatile where it's not a specific number, but just relative to this scene. So what I do is I'm going to scene manager, I'm going to get the active scene. This function, getActiveScene, returns the index of my current scene based on the build settings, which again, if I change my build settings later, this code will still work, right? And then I'm just going to get the build index. Sorry, it's going to get the scene, but we're going to get the index from it. And I'm just going to add 1. Because remember, in our build settings, if we set the order correctly, then we just want to load whatever comes after the main menu. So later I could change that, and then this script will still work, right? You could also just put directly 1 if you want, or the name of the level, right? So for example, like this, load scene, and then parentheses, the name of the scene. So it's kind of up to you. I do it like this so that if I change the name of my scene later, I don't have to worry about changing the script. So let's try this out. So when you play test your game, your quit doesn't actually do anything because an application's not running. So to test that out, you'll have to build your game, which I recommend doing, but for the sake of time, we won't do that right now. But we click start game, and it starts our game. right? Because it loads the next scene. And then it works like it should. Awesome. Which makes our main menu basically complete. That's a very simple main menu. But from there, you know how to set up buttons and how to make them do things, and so you could easily add other things to your main menu as well. But this is all we're gonna do for the main menu here. Okay, I know we're moving along pretty fast, but maybe after this section, I'll do like a halfway point checkup and see where everyone's at. But we have our main menu, which we talked a little bit about the UI there with our canvas, and now I want to go more into that and also cover the UI that we have for when we're in the level, right? So, in Unity, as you kind of saw, all the UI is stored in this canvas component that's auto-generated for you. You can also create it yourself, because here this picture shows all the different things you can include in your UI. I usually only use text, images, and buttons, but there's other things as well. Essentially, those anchors that we saw, the canvas kind of allows for us to do that. And because it's UI, the canvas also allows us to scale the UI to different dimensions of different computers, right? So if I'm playing on like a square monitor and somebody else is playing on an ultra-wide monitor, my UI will still look good, right? So that's kind of what the canvas allows you to do. And of course, simple ones that we use, and then others you can explore. So what we want for the in-game UI is we have a health bar. So we have those hearts that are part of the script bundle or sprite bundle I gave you guys. We have heart images, which will display the amount of health the player has. So we're gonna have a health bar that kind of takes care, as a parent, it's kind of like a folder for all of those. And then we're just gonna have two different texts. We have game over and then you win when you reach the goal. So just two different texts that display depending on what happens, right? So lots of stuff on the screen, but I'll do that with you guys. So this is kind of what we want at the end based on the right here, where this is kind of what it's gonna look like. So we're gonna go over to our editor and do that. We're gonna jump back to our levels scene. Okay. And then we're going to right click here or, create, I'm just gonna create a canvas directly and name it UI. And then I'm going to create I'm actually gonna create an empty game object called health bar, because I don't want my health bar to actually have any UI information. It's just gonna be kind of like a folder. And as you see, it's gonna be part of my UI. And then, if I right click on my health bar, I can create an image, and I'm gonna call it heart. Okay. So as you notice, your UI is way bigger than your actual level, because it's really large. So this is an image. This is what it comes down to. So it's similar to a sprite, but it allows us, again, for us to be anchored, and do different things. So our source image is going to be the UI. Finally, this UI health comes into play. It's going to be this heart. And then in our UI here, we're going to set this to 32 pixels per unit as well. I'm not sure why I can't, anchors. Why does this not come up? That's awesome. Hold on. Is it because I have to do, let me try this instead. If I do image, okay, now it pops up, okay. I'm just gonna, I guess, redo it by creating the heart first. And then making an empty like this. Okay, I see. I guess Unity cares, but we want it to be a child initially when we make it and not like create one and then drag it to be a child. So make sure that you have this clicked on and then you right click on UI to make your child. Because now we have this anchor. So for the health bar, I want this to be actually anchored in my top left. of, sorry, not the heart. The heart actually is fine. My health bar to be anchored to the top left. Okay? So I'll have some, I guess, like, okay. This will also, I suppose, be top left, where it's going to be 0, 0. Why is it doing it? Or is it going to be center? Okay. I think the main thing is the health bar is top left, and then the heart, you can just kind of play around with it because this anchor is relative to your health bar. So this kind of, you can play around with relative to the health bar. So I guess this one will have position 50, negative 50. Okay. And I'm going to make this a little bit smaller. So I guess maybe like 30, negative 30. So you play around. So it's going to be kind of like that relative to our corner. And it's going to be under the health bar because the health bar as a whole is going to be top left. So then this, I'm going to actually make a prefab, which maybe you don't have to. It's kind of personal preference. I'm just going to actually just duplicate this a bunch. My idea, and I guess I'll go over this now, but a common technique is to have, instead of creating and destroying objects, you have a bunch of them and you just disable and enable them based on what you want to happen, right? Because it's better it's just faster overall to create things, to reveal things rather than create things. So I'm just spacing these out. So they're 50 apart each, so.
You could probably create a system where the amount of parts there are matches the amount of health you have, but I understand we're short on time.
Well, that's what we're going to do. We're going to make it so that it actually matches the player's health. But in terms of setting up the health bar, we're going to, essentially, we're creating all these hearts, and they're going to exist, but we're only going to show them depending on how much health the player has.
That's kind of what I'm saying. The amount of parts that exist match the amount of parts that the player has, and they won't be disabled or hidden.
Well, that's what I was saying in terms of it's faster and better practice to disable and activate, as in hide or reveal things rather than create them from scratch. So you could do you definitely could do the method of just creating it, but then imagine if the player like loses health, gains health, then you have to destroy it completely, create it back completely. In this way, you just activate it. So it's kind of like, I guess, just good programming practice, good Unity practice specifically. That's why I made a bunch of extra ones. And then the other two things that we want to make as children of our UI is text. So this is going to be text game over. And this is going to say game over in our text here. And I guess I'll make the color like red because you died. And everything else is fine. You can change like the font size, the text style, the font. I'm just gonna make this quick and dirty, so I'm gonna keep it default like that. And I'm gonna create one that's called text level finished. It's gonna say you win. And I'll justify it to the middle and make it green. Awesome.
It's just easier to change what the text says?
You could do that too.
Okay.
There's different ways you could do it for sure. I'm just gonna, actually what I was saying before is disable and enable it. So if we don't want this text to be on screen all the time. So you disable it by checking this check mark here. So now it's not on our screen, right? And we're gonna enable it only when we want to, when the player, reaches our goal or dies. So this just talks a lot about what we just did. There's a link here that's talking about the different anchors. I think it's a video that goes over the different types and why you want to do that. But again, a little short on time today. And then real quick is this canvas scaler, which is, even for me, still kind of a confusing thing because there's a lot of options. But I linked a video at the end here that goes over every single type that you can view. But basically, I have these settings that we're going to apply that kind of work for all the projects that I've ever done. But essentially, this canvas scaler component is what makes your canvas, your UI, change depending on the display screen, right? Your resolution that you're playing on. Because I can show you, I'm gonna pop this out, maybe if I can. I'm just gonna, okay, close you, and then open you again. Okay, because we can pop this out separately. And just, as you can see, our health bar is still in the top left, even though we have this crazy like iPhone resolution, right? And so when we move things around, it actually is pretty good. But as you can see, even if we have a really large screen, our sprites stay really tiny. They say top left, but they say tiny. So what we want to do is we go to the canvas scaler. Right now we have constant pixel size, which is why they stay tiny. They stay the same size no matter what it is. So we change that to scale with screen size. And then the settings that I use personally, which is, I guess, here, is this 640 by 360 with in between width and height. I get these numbers by taking 1920 by 1080, like a standard resolution, dividing it by 3. Personally, when I make games with WebGL, which is basically you can publish and run a game on a browser. So for example, itch.io, you can play in the browser. It matches the resolution that's like stated here. So I make it really small so that it fits on web browsers. And then here it's going to match in between the width and the height. So whichever one makes more sense, it's going to kind of figure out for us. And so that's what I'll do right here. So 640 by 360. And then match 0.5. So now when we have our game here, okay, so now our UI looks good, right? So see? We have the hearts kind of stay the same relative to everything else that we have, somewhat. It's a little janky, of course. That's why it's like, hey, it kind of works most of the time. Because no one really plays on a monitor that wide most of the time. And also, if you're making a mobile game, then you're going to make a mobile game from scratch. So for our purposes, this is totally A-okay. And that's more about that's Canvas Scaler. If you want to learn more about the different types, there's this video that I linked. Okay, now that we made the UI, we're going to update it in our code. And so essentially we're going to create a new script for health bar, and we're going to create a function that updates the health depending on like a parameter that it takes. Okay, real quick, do this really quick. Create a new script. Because I don't want to keep you guys late after 8:30 if I can avoid it. So health bar, awesome. I believe this one won't have too many things. Okay, so we're gonna get rid of this because it doesn't do anything on start and on end. But I make a function, typically, private void set health, and it's gonna take a parameter of health. Right? And what we're gonna do is we want to, in our script, we're gonna attach, I'll do this now. We'll attach the health bar script to our health bar. We want this health bar script to take a look at all of the children of this object and activate or deactivate them depending on how much health is being passed in as the parameter. So essentially what we're saying is, if the parameter that we get is 3, then we're gonna have just the first 3 children activated. So that's why it's important to have the heart that's at the top to be the one that's on the left. Otherwise, you'll have like 3 random ones activated. So again, when you organize this, make sure that the leftmost one is at the top, and so on. So to do that, we're gonna have a for loop, and then we have a simple declaration of a variable called I. And the for loop is only gonna go on for a certain amount, which I will change this. And we're gonna increment I. It's typical for loop fashion. But what we're gonna increment over is child count. So the transform keeps track of how many children this object has. So we're gonna say while I is less than our child count, because if we have 3 children, they have index 0, 1, and 2. So this is what we want. We don't want I to be equal to that. So that's why it's only less than. And we want to basically, again, access and set them active or not active, depending on our parameter here. So we're gonna say if the child that we're looking at, which is I, so let's say the first child, 0, has an index of 0. If it's less than health, because if we pass in 3, we want the first 3 children to be active, those children are gonna have indexes 0, 1, and 2. Right, so the uppermost index is gonna be less than the health that we want to activate, which is why I have it, again, not equal to health. So if we have it that the index that we're looking at is less than health, we're going to get that child and then activate it. So, again, we access children through the transform, and there's a function called getChild, and we're gonna get the game object of that child, and then there's a function called setActive. And I'm gonna set it to true. So if you remember in our inspector here, there's this little check mark for in the inspector for setting things to be active. This function takes care of checking this box, right? So that's what that does. And then we do essentially the opposite for if it's not included in our health. So we do the same exact thing, but just set it to false. So essentially, set active false is like deactivate it. So it's a little, I know it's kind of a lot and it's really long. I did look this up on like Stack Overflow, and so I referenced that a lot. So I personally was like, how do I do this? I looked it up. That's how I got the answer personally. So that's the website I recommend. Now I wanted to show you guys, but I think with time I can't. Essentially, what we want to do is that the player, when they take damage or heal, the player script tells the health bar script how much health it has, and it calls this function setHealth. Because what we can do is in our player script, we can say setHealth, parentheses, and then you pass the health in, right? And what you could do is similar to how we did here, where we get the component. We could have a field that has a type of health bar, and then we save the health bar component, and we do health bar dot set health, right, this function, and call it that way directly. But it's a little janky. It works, but it's not the best for, because then the player has a direct reference to health bar. And I'll go over just after this about why we don't want to do that. And then also, obviously the player's health or the player reaching the goal has to do with the text that we made, right? This text that is disabled, we want to enable it. But the player, as a script, shouldn't know about any of the UI stuff, right? Because the player only knows about the player and anything that has to do with the player, not with any of our UI. So how do we do this if we can't let them communicate directly with references? Events. That's simple, but not simple, but it's okay. It's actually not bad. So events allow for us to have the player and the health bar in a way communicate without directly knowing about each other's existence. And that's what we want. So what we want is for our scripts to kind of communicate with one another without having direct references to those scripts, right? We don't get those components. So for example, the player can communicate how much health the player has to the health bar without having a health bar component in its code, right? And also events allow for us to follow good object-oriented programming practice, or OOP, object-oriented programming. So there's a link for what Wikipedia defines as object-oriented programming, but obviously for Unity, that's what we have, because all of our game objects are objects, so we want to follow this. Essentially, any object or any function should only know what it needs to function. So again, in our player script, the player script only handles, for example, well, things have to do with the player. So if the player is moving, if the player is taking any damage and colliding with things, animations regarding the player, right? The player should not have to know that there's a health bar on screen. The player does not know that there's text or that there's an enemy or something like that. It only takes care of the player, right? And same thing with the UI. The UI should not know that there's a player object. It just knows that there's something going on, right? So how do we communicate information between these objects? Well, we have events. So it is good programming practice. It looks intimidating, but it will make your life a lot easier and your code a lot cleaner. So the idea of events is that we have an outline for the type of event that we have. So like the name of it, for example, X, and for example, it could take an integer argument. So we tell it what type of arguments this event takes. And then for each, we have basically two lists for each event. We have objects that basically say, hey, this event happened, and then the objects that do something when that event happens. So there's different names you'll find online. I use personally invoker and listener. So invokers say something happened, listeners say, okay, I'm listening to this event, I'm gonna do something. You can also find online callers and handlers or subjects and observers. So there's this lovely diagram I made. Essentially, you have this invoker that says, well, I'm gonna yell out into the void that this thing happened, and I don't care who's listening. I'm just gonna say, hey, X happened. Hey, anybody's out there? X happened. And then they don't care who's listening. And then we have our listener, and then they're like, oh, I'm listening in. Somebody yelled out that X happened, so I'm gonna go do something. But I don't care who said it. I just need somebody to say it, right? So this is kind of how events happen. So as you see, our invoker and our listener don't directly communicate, and we don't want them to because we want them to stay sad and lonely. And so, again, lots of text on screen. I will be doing this with you guys. And to implement that, we will have an event manager script, and then essentially we'll be programming the invoking and the listening in our individual scripts. So, real quick. So, a new lovely script that we have. So, as we do per normal, we have a new C# script. We're creating lots of them today. I'm gonna call it Event Manager. Awesome. And so, for our Event Manager, it's not gonna be a pretty long script. And the thing is that this Event Manager will only declare the type of events that we have. It's not gonna do any functionality, and it's actually not gonna be tied to an object either. So you remember how for our other scripts, we have to attach it to an object in our hierarchy. For this type of script that we're gonna have, we don't need to do that. Because, again, it doesn't do anything in the actual game. It's actually not gonna inherit from mono behavior. So we can get rid of that little part after that says mono behavior. We can get rid of it. We get rid of update and start because it doesn't do anything with that. The thing that we want is this keyword before class that says static. And static is a keyword, which I don't think I provide a link on the slides. Essentially what this means is this class and this script does not associate with any object. So in object-oriented programming, everything is related to an object. So essentially you have your player script is related to your player. Our event manager is not related to any object. So we tell the program that by saying static. And essentially, yes, we exist and run. Also what we do actually, well, it's already public. So when it's static, other scripts can access and they know that this script exists without getting any reference to it in a variable. Like you don't need to do get component to get this class because it's static, and it's also because it's public. So that's the power of that keyword. And we define events with public delegates, and delegates are a big thing in programming, and even if you're a computer science major, it's a little confusing, but it's a type of thing where I tell you it works, and so you just kind of follow it, and runs well. But if I provided a link there if you want to learn more. Essentially, it's just a variable that is a function. So you know how you have, for example, up here, you have fields here that are like, you have integers, you have booleans and floats. We're going to have a variable that has this type of name that is a function. And so we call that by calling the variable. So it's really powerful. It is kind of in advanced programming in a way, so I do apologize, but it's not too terrible. So for example, we have an event. So for example, okay, so some interactivity, I suppose. If we want our player and health bar to communicate, what type of event should we have? What should its name be? What do you think? So it could be something simple, like health change event, for example. So we're gonna have the name event at the end so people know that it's an event. And this type is going to be public because we want other scripts to know that this exists. It's gonna be public delegate and health change event. And then, okay, so see, let me get rid of this. So public delegate, that's kind of our prefix. So public so that other scripts can see it. Delegate saying that, hey, this is a type that is a function. And then we have that function header, but here. So remember, in our functions here, for example, we have this return type at the beginning before the name of the function. So we have, let's say, for example, down here, we have like void flip, and then any arguments in the parentheses. We do the same thing here. So we have void health change event. So these are going to be, it's a type that we're making. This is going to be like a function that returns nothing, and it's going to have one parameter with health. And the reason why I put a parameter there is because we have a parameter here in our set health function, right? And then we actually create it as in something that other scripts can access by doing public static, which again has the same keyword static, so that other scripts can use this directly. And it's gonna have a type of health change event. So see how it's like a teal color? That's a type. White is actually a variable, and I'm gonna name it on health change, like that. So this is kind of like a variable that is a function. It's actually also a series of functions. So we can actually attach, well, again, you can have multiple listeners, right? So this variable, we can attach multiple functions, and when we call this variable, it's gonna call all of those functions. So it's pretty powerful, and I'll tell you how to use it. So by typical event naming, you have the word on to indicate that something, like an event has happened. So on health change, which means when this event has occurred. Yes, so let's see. We have a static class, we have events, and then I'll tell you how to add listeners and invoke them. So I'm gonna add now, rather than later, I'm gonna add our other events. The other two events that we will have is when the game ends, when the player reaches 0 health, and then when we finish, when the player reaches the goal, right? So in similar vein, I'm gonna I won't copy paste, but I'll have another delegate. This time I want a function that doesn't do anything and doesn't take anything. It's not gonna return anything, and it's not gonna take anything. So it's gonna return void. I'm gonna call it game over event. And it doesn't take any arguments because game over doesn't really need to know anything to display the game over text. And in similar fashion, static game over event on game over, right? And I'll copy paste this one. So we'll have level finished event on level finished. I call it level finished because if you want to make multiple levels, not just the one, then this event will be, is what that does, is when you reach the goal. So this is the event manager script. We won't edit this anymore. So I know it's kind of confusing, but it's once you set this up, you can use it pretty easily. So at the bottom here, I talk about how to add the listeners and invokers. So we have our invokers, which say, hey, this event happened, and our listeners that say, okay, I'm going to do something. We're going to, I'm going to go over the invokers first. So going back to our health bar, we want the health bar to actually do something, depending on the player's health. So to do that, I want to invoke this event whenever my player's health changes. And actually, I'm going to also set it up at the very beginning, because I want to have like the beginning amount of health to be displayed correctly. So I think I did this here. Yeah. So in our start function, when the game just starts, we're going to have our health bar be set to the health that the player starts with. So we can do, look, if we type event manager, we are able to access these events, right? So on health change. And then we pass in our health here. So that's kind of how you use it. But we want to make sure that this function is not empty. Essentially, if it's not null, because if it's null and then you try to call it, it's going to break your game, and you don't want that to happen. So we just want to do a quick check. If event manager.onHealthChange is not null, then we call it, right? So if it's not null, then we call it. Another way to do this shorthand, which you might find very useful, is I believe it's like this, or not. Never mind. I think that's a different type. You can basically, there's a question mark, which is a shorthand for checking if something is null, but I think it doesn't apply here. So we set our, and I'm just gonna copy paste this to other places. So if it's not null, we're gonna call it with our default health, which is 5. So that's in the start. But we also want to do it when we take damage and when we get a health pickup, right? So I'm going to go to where that is in our code. So we have here damage. So right here, health decreases. Instead of my debug now, I'm going to get rid of that, and I'm going to put my health change. So now we don't need to log our health changing anymore. We can just put it in there directly. And then also here, when we get our pickup, right? So that's invokers, right? Nice and easy. Again, you can access event manager directly. You can access on health change directly, which is pretty awesome. To do listeners, what we do is we add this function to the variable, kind of like we add it in a way so that it's part of that variable. So I'm actually going to, so we want to do that when this script becomes active, the health bar script becomes active. We're like, okay, once the script is loaded, add my set health function to that event as a listener. So there's a function called onEnable, which is built into Unity, and then also alternatively onDisable, which, why are you not coming up? OnEnable, onDisable, provided by Unity. It's called by Unity. This is saying when we enable the script, when the script is enabled, and then when the script is disabled. And essentially, what we do here to add it as a listener is get the event manager on health change, and we do this like that. So we have, so remember this plus equal signs is saying add this on the right side, the set health, to on health change. So we're not setting on health change to be set health, we're adding it because we can have multiple listeners, remember? The important thing is that when you want to, essentially this is like subscribing this event to be a listener, you also want to unsubscribe the event from being a listener if the health bar for some reason goes away, which it shouldn't, but just in case it does, to not break your game, you want to unsubscribe it when this is not active. Essentially, if set health can't be called anymore, we want to get rid of it. It's, again, good practice so that your game doesn't break. And all we do there is the minus sign. So we just unsubscribe it from the event. Okay? So it's a lot about that. Let's try and test it out. So Remember, we had 5 health as our default, and then when I take damage, now we have 4. And then when we gain health, oh, well, you saw it really quickly. But look, it works. Isn't that magic? I would call that magic. I love events. Events are so useful. And then we die pathetically. Okay. This slide is talking all about that, about listeners and invokers. We already did that actually, the event manager. And so here's a little bit more about what we want. So we did this top one, right? We did the on health change. Invoked by the player, we already did that, we implemented that. Listened to by the health bar, we already implemented that. Then we have these 2 other events where game over is invoked by the player when the player reaches 0 hit points, 0 health, and then level finished when the player collides or triggers with the, I think I caught a piece of that. It's when the health, when they get to the flag. When the player, okay. But it's kind of like, what is this listened by, right? Because we want to activate our text that we made, but what does the activating, right? It's going to be a really simple function, but what does that? Because again, good object-oriented practice is, well, we have something that like takes care of that. So we don't want the player to take care of that. We don't want our health bar to take care of that either. And so that segues me into the game manager. Okay. Let me. Ooh. So, what is a game manager? It's a script, right? It's just a script and a game object that handles changes regarding the state of the game. So for example, we have our level that's in progress, we have the game over, we have the game win, or like the level finished. Those are different states that your game can be in. It's special because there's only one, so when you actually create a script that is titled exactly that, it has this little gear icon that pops up. Don't worry, it's a little script, it's just unique because people use it all the time. Essentially, this is going to be our listener for when your game ends or if your player reaches the end. Because the game manager, again, takes care of state. So this is going to be like, oh, okay, now we win, so now I'm going to display the text, right, and other things. Ideally, you have some sort of like variable that keeps track of the state, and you give a name for the state, and it's like really nice and official, which I will provide a video at the end if you guys want to look into that. But frankly, our game is really simple, and that's a lot of work, and I don't want to do all that. So what we're just going to have here is 2 event listeners and 2 different functions that do things based on those events, right? Okay. I guess. Okay. Yes. Before we jump into it, I also want to cover singletons because when we implement things, implement the game manager, we'll be using this. But essentially, again, that's a link. But a singleton, so there should be only one game manager for the whole game, right? We don't want multiple objects to being the game manager. And so it comes to this common like idea or implementation or thing in game development or object-oriented programming called a singleton. A singleton, as the name suggests, is there's only one of it, and it's globally accessible. It's a class that any script can access and like do things with. There's only one for the whole game and one per scene. They're typically used for things that have one instance of, so I find it only applicable really to like manager type scripts. So our game manager and next our audio manager, which we will hopefully get into. And we have this, you can tell if something's a singleton if you have this variable called singleton, or online sometimes it's called instance because there's only one of it. This is what it looks like, by the way. So this right now is from a screenshot of the game manager script, so we'll be implementing this. But this can be for any script. So if you kind of see this type of code, you'll be like, oh, this is a singleton, right? Because we have this static singleton variable, and then if this singleton variable is not defined, we're going to define it, but if it is defined, we're going to destroy this object, because we don't want multiple of it, right? So I will get into that when we program our game manager. So I'm going to, again, jump into the editor, but essentially we'll just have, the outline for it is just 2 fields for the text. We're going to have that singleton implementation, the code for that, and then 2 functions that listen for our events. So, back in our editor, we have another lovely script that we make. So, script. And I'm going to call it game manager. I suppose, there we go. And it changes to a little cog, which is awesome. That's what we want. So, this one is, I don't think, yes, we don't need these because the game manager doesn't do anything. You might have a game manager that does stuff on start, but ours does not, so I deleted those methods. So we want to have fields for just game objects of text level finished, and then game object text game over. And I have the type game object because all I'm doing is disabling it and enabling it. I don't care that it's actually text. I'm not changing the text. But if you want to have the idea of changing the text rather than enabling it, then you could have the type be like the text field itself, the text component itself. And then I personally want these to be, you can drag and drop these in the editor. So I'm going to serialize them so that they're accessible in our editor, or our inspector specifically. And here I'm going to have our singleton implementation, okay? So we want a public static game manager called singleton. And I know it's a bit funky, but inside of our class, we can reference the class itself. So I know it's like a bit weird, but we're just saying, if we're in the script, we only have one instance of this script, and that's what this will be checking for us. So I'm going to use this on enable function again, which runs, on enable, which Unity runs for us, and I'm going to have that singleton pattern. So if we have our singleton is null, or again, you can use the exclamation point, how we used last time, then we're going to set this to this. So there's a keyword this. This, in blue, refers to this instance of this script, right? So if we don't have a singleton instance, then this is going to be our singleton instance. And then we have this lovely function that doesn't want to autofill for some reason, called don't destroy on load. And essentially what this function does, it tells Unity when we move between our scenes. So let's say you start in the main menu and then you'll move to your level scene. It's just going to tell Unity not to destroy this object, because obviously most of the time you destroy all the old objects and you load in all the new objects in the new scene. So we're telling, hey, this singleton is really important. Don't destroy this one when we move between scenes. It's very typical that you'll find that. Otherwise, if we already have a singleton and for some reason, just in case, because again, saving yourself from yourself in a way, in case you do have multiple of these, we are going to destroy this, we're going to destroy this game object. Right, so if we already have an instance and now we're actually checking that this is also an instance, like, okay, I'm just going to get rid of myself. And then, let's see. And then we have two functions that are going to be listeners for our events, right? When we have our game over or level finished. I suppose first, I'll populate these fields so that we have access to the text. So what I'm gonna do is actually I'm gonna create an empty object called Game Manager. And all it does is it has this script attached to it, right? So that's the only thing that'll have. And then we get this text by dragging and dropping it like so. So now we have our fields populated, which is awesome. And inside of here, we want to just activate them or just activate them actually. I guess you can deactivate them if you were planning to go like back to a different menu later, for example. But I'm gonna have a new function, private void level finished, which is the listener for when the player finishes the level. And then a new one called game over, which is the listener for when the game is over. So what I want to happen when with either the game over or the level is finished is I want to pause the game and say the game's not running anymore and then display the correct text. So in both of them, I'm gonna use this thing called time scale. So time.timescale is, well, the scale of your time. So 1 is, it's kind of like percentages. So 1 is 100, 0 is 0. You could do like 0.5 to get 50% if you want to have like some sort of slow motion moment, for example. So you can play around with that in your games if you want. But typically, if you want to pause it, you just set your time scale to 0. And I want that for both of these. So I'm just going to paste it there. And then what we do here is what we did before with our children is we have this text level finished, and I want to set it to be active. And then here we have text game over, and we just activate the correct text in these two functions. And again, these are listeners, and so we have to subscribe them to the event. So I'm going to go back up to actually my on enable. Once the script is enabled, then I'm going to subscribe event manager on level finished, and then event manager dot on game over is game over. Oops, game over. Right? And how we had before is we have on disable, and essentially I'm just going to copy paste this, and we unsubscribe them just in case somehow our game manager gets disabled at some point and then these events try to be called. Because again, just keeping it safe rather than risking it. And so, let's see, I believe this is our game manager. That is our game manager. So, we will playtest this. As you can see, there's actually, on our hierarchy, when we play the game, there's this don't destroy on load, and our game manager actually goes into that little folder. But let's say I just get rid of all my health real quick. Well, okay. I forgot that I set the invulnerability to 2 seconds. Okay, there we go. Oh, I didn't invoke it. That's my fault. We listened for it, we don't invoke it. So, let's go to our player script and invoke it. This time, compared to health, we only will invoke it when one time. And so instead of this you died log, I'm gonna say if event manager dot on game over is not null, then I'm gonna call this, right? And then the other one is with our goal or finish. So instead of saying debug log goal reached, I'm gonna say on level finished. Okay, so we invoke it. That's my fault. So let's actually test it out again. I'll test out the game over first. Okay. Okay, boom. It's pretty good. That's good. That's what we want to happen. So that kind of looks more like a game. You have. I mean, if you start from your main menu, then you can load into this. When you die, game over. If you want to include some sort of button to restart the game, you guys know how to add buttons, you know how to add UI elements, you know how to essentially match functions to your button. So you could easily add a new button that says retry, and what you do is actually you can load a scene, but you can just load the current scene and it'll like refresh it, right? So you can load this scene again to restart the level. That's like a fun fact if you want to try that out. And then let's try with when we reach our goal here. So I get this cool, and then awesome. And as you can see, I was invulnerable when I reached my goal, but the time scale is set to 0, so that timer is never, expiring. So we win, and that's pretty cool. So obviously this level sucks, but you know how to make the level much bigger. You can add platforms, you can add enemies. I know the enemies don't move, but I will, I'm hoping to provide some sort of like zip file with the script that I added to make the enemy move if you want to have moving enemies. I'll upload that to GitHub and send out a link with that you guys can take a look at if you're curious. The last thing is the audio, but what we want is to define a sound object, essentially a class that is our sound with our own custom fields. And then we have a manager script similar to game manager and event manager. It's going to be called audio manager. It's another singleton, and we have this dictionary that saves the sound class relating to the name of the sound, and then we have a function that plays that depending on what name we give it, right? And so how audio works in Unity is there's two separate components. We have the audio source and then the audio listener, which is pretty self-explanatory. The audio source is attached to the object that you want to make the audio happen. And then it's more noticeable if you have a 3D game, but obviously if you attach it to the correct things and then you walk around, you have this spatial 3D sound. But you could somewhat do that in 2D as well if you want. If you don't want that in a 2D game and you don't care about that kind of moving back and forth, left and right, you could just attach it to your main camera. And then obviously we have our audio listener. By default, it's attached to the main camera. Most of the time in both 2D and 3D games, the main camera is like your player camera. So your listener is attached to that. And that's what we'll be doing with our. So we have our sound class. So this audio source, as you can see, has a lot of different parameters like volume, pitch, priority, the actual audio clip file. So we can have a dictionary that's like name to audio clip, but then we can't modify these different parameters without kind of in a way manually doing it in the inspector rather than it's not the best to do it. So what we have is a sound class that keeps track of the clip and the volume, for example, inside of the class, and then we can just reference that in the script. And then so we have our own type called sound, and I'll jump into the editor again for that. So another script here, I'm going to call it sound. It's representative of a sound clip. So you could also call it like audio clip or sound clip, but audio clip already exists inside of Unity, so I guess you could call it sound clip if you want, for example. But this is actually going to be a class in terms of good old C# class and not a Unity object. So like our, I think it was like the event manager, we don't have this actually. So it's not going to be like a mono behavior. It's not going to have start and update. It's just going to have fields. So the fields that I want it to have is a name. So I'm gonna make this public, of course, so that we can access it outside of the script, which is the whole point of the script. And then we have an audio source. And then we have audio clip. And then we have a volume. And you can add others as well that are part of the audio source, but for us, I just want this. And I'm actually gonna make this serializable, but I wanna have this cool little thing, mostly because I found this in a tutorial and I thought it's really cool. You can have a serializable, but instead of typing in a number, it's like a little slider. So it's called range, and then you give it a range. So it's going to be from 0 to 1, because you have 0% volume or 100% volume. Makes sense. Last thing is up here is we want to have this whole thing serializable. Essentially what this does, what serializable says is that, hey, this class can be serialized and this class can be dragged and dropped inside of our editor so that when we have serialized field, we can drop it in there. Okay? So that is the sound class. This, again, is just saying what I just said. And then we have the audio manager, which I will go through real quick. And it's has also the singleton implementation, and it has some, no listeners, but it's just gonna have, like, we create all of our audio, and then we play it with a function. So here, in our editor, we're gonna create a new script called Audio Manager. And then this is going to be a singleton as well. Let's see, audio. So I'm gonna set up the, I don't think this has start. Yeah, it won't have starter update on enable. We have if our singleton is null, then singleton is this, and don't load, which is the game the game object is the game object associated with this script. So this keyword is actually talking about the script instance, not the game object associated with it. So just a little bit of, I guess, fun fact. So we have our singleton here, awesome. And what we want, I'm gonna double check, is to have essentially a list of sounds that we can edit in our inspector, and then a dictionary that references the name to each sound clip that we have. So I'm going to create this list. So private sound, which is the class that we just made. I'm gonna make it a list easily by adding these little brackets. So now this is a list of sounds, so I call it sounds. And we want this to be populated inside of our editor. So I'm gonna serialize it. The other thing we have is not serialized is our dictionary, which is a new type that we haven't talked about yet, where essentially every data point in here, so like a list is self-explanatory, it's a list of things. A dictionary has key value pairs. And so I think I talk about it. There's a link here, you can look into this, but it's a type of data structure, and it's key : value pairs. So essentially for our, we have string as a key and sound as a value. And then what it does is that when we give it a key, when we give a name of a sound, it's going to give us back that sound value. So dictionaries are helpful with kind of like, hey, I give you this identification code and you give me data in return. So it's very useful because we're going to use it in our function later. I suppose since we create our sounds here, or the list here, I'm going to actually go populate it in my editor by making an object called Audio Manager. And then, because our Audio Manager is a singleton, but it's not static like our Game Manager. And as you can see in our inspector here, we have this little drop-down, sounds, and we can populate it. So I can add a little plus sign. And we see that it has the fields, this name, source, clip, and so on, that we defined in our sound class, right? So I'm going to use here the sound clips that I made. Where are they? Where'd they go? Okay. I downloaded, yes. So I provided on GitHub these sound effects, which you can access with this tinyurl gdg/sfx. But essentially, real quick, I'm gonna just import them in a new folder called audio. And then I'm gonna drag and drop them. The folder has a README, which is, I just tell you where I got these from if you want to see where I got them from. But we have our audio manager, and I'm gonna call, so we have 3 sound effects. We have player damage, player jump, and player land. So when the player takes damage, when the player jumps, and when the player lands. So I'm gonna have, for example, player damage. This is the clip, and our source, I'm gonna put the audio source on my camera, right? So back in my audio manager, I'm gonna drag my main camera on the source. And then the volume, I guess I'll make it, sure, 70%. And you can tweak it easily in this audio manager if certain sounds are louder than others, right? And I'm gonna add 2 more. Player jump. And this is gonna be player jump. I guess I'll make that 100%. Oops, and then I don't want that. Oh, boom. This is gonna be player land, and this is player land. And that's fine. So these all have the main camera as the audio source, and the main camera already has a listener. See, this listener, which is awesome. So we populate our audio manager with our different sounds, and we want to save it to the dictionary with the name here that we provide. This is the name that we want to save in our dictionary. So when we give the dictionary this name that we defined in our inspector, it's going to give us back all this other information for us. So we do that by, well, first we create a new dictionary. This is not audio name to sound. It's a new dictionary of type string because it's a name, sound, and then parentheses because we're creating it. What do you like? What? I guess, oh, do I need, no. I don't know why it's yelling at me. I guess I will ignore this. The computer has been a bit buggy. So I'm just gonna, okay. Private dictionary. Oh, my bad. It's because this is outside of a function. Sorry. This is supposed to be inside of our function. There we go. Okay. And then I'm going to have another loop type, which is very powerful, called for each. And so we want to go over our list of sounds and do something for each sound. So I'm going to say this. For each sound in my list of sounds, and each sound has a type of sound, right? It's a mouthful. I'm going to add to my dictionary. So we say dictionary.add. The key, comma, the value. So the key is the name and the value is the actual sound, right? So we have sound.name and then sound. So because .name is because our sound class has this public name field, right? It's a public name field. So that's how we can access it directly. And sound just refers to the entire sound. And then just in case, I guess, okay, that's fine. Just in case our sound does not have a source for some reason, because maybe you forgot to add it, or it's by design, then we're just going to say that this audio manager has an audio source. So you don't have to add this, I suppose. By design is the source is optional, and then if you don't provide it, it will create one for you. So this is saying if the sound doesn't have a source, then we're going to give it a source that's attached to the audio manager object. And then, we're going to add to the dictionary after we do that. Okay, final function is actually playing the clip. So we have the name. It's going to take the name of the audio clip as an argument. And what it's going to do is we're going to get it from the dictionary. So with the dictionary, you can access the value that is related to a key by passing in the key in square brackets, right? And we're going to save this to a variable called sound. So we give the dictionary a string that is a name, and it's going to give us in return a sound, and so we save it to a variable. And then we go to the source of that sound, and there's a function with each source that is play, or we say play one shot. And play one shot, you can hover over it. It both plays a clip and scales it by the volume inside of the function call. So I could do this, sound.volume. Oops, clip.
I'm proud of all of you.
You should just grab chips.
Actually,
You can grab more if you want.
yeah, I'll just bring them to the practice because we're just 1 away.
Are you there for a while?
Yes.
Cause you can just come back when this is done and then pick them all up.
Oh, okay. Yeah.
Cause we're gonna be finishing. I'm just running a little late, but we're like almost done. So you can come back in like 10 minutes if you want.
Okay. Thanks.
Okay, so then we play the clip with the volume that we specify. Okay, the last thing for this to work is to actually play these audio clips, and the only place we do that is in our humongous player script when we land, when we jump, and when we take damage. So we say, where do we start jumping? So I'm gonna say, right here, we're jumping. So actually first we gotta do is add another reference to an audio, I think it's audio manager. Yeah, audio manager. Because we want to get the reference to the audio manager, right? So we have a variable called audio manager. And inside of here, instead of get component, because the audio manager is not a component of the player, what we can do is find it by the type, because there's going to be only one of it. So we have audio manager is find object of type, which is a built-in Unity function which finds an object of this type. I think it finds the first one. Here, I can hover over it. Maybe not. You could probably look it up. I would assume it gives you the first one, but this is fine because it's a singleton, so we only have one. And we're going to save that as a reference in Audio Manager, because then when we are jumping, we just say Audio Manager play, and then we say player jump, and that's it. So when we are not jumping, we say player land. And when we take damage, we player damage. And you want these names that you say when you pass to play to match the names in your inspector here. So if you change the name of your audio here, you have to go back in your script and change. So that's the one downside to this method. But obviously I recommend just creating the audio clips at the very beginning and then implementing it and then just not changing the name of it. And so the other thing actually, so when we test this out, I'm gonna play it on the laptop. It's not connected to the audio on the speakers. We have our audio, okay? Nice and easy, I suppose. Once you set it up, it's really easy to add things to it. I think the last thing I want to do is make sure that this does not have a filter, because they look fuzzy. Because now our hearts don't look fuzzy. They were fuzzy before. I just noticed it. Okay, so that's our audio. So that's essentially the end of the game. You can change the levels to be what you want. You have enough knowledge to add buttons if you want to add a pause menu, for example. If you want to have a button that says return to menu or restart level, you can do that on your own. I believe in you. And then also I will upload the final version of this that we have to GitHub so you can play around with it. Again, I mentioned we have this enemy. At the very long time ago, I showed a version where the enemy moves. So I'll upload like maybe a zip file that has those assets so you can kind of play around with it. But I have a bunch of videos here because I know I went through a lot and I didn't check in with you guys, and I'm sorry. So these are a bunch of videos that I kind of referenced and I think are really good for what we covered today if you want to get more practice in. A reminder, we have the game jam tomorrow, but I think you folks already know. And then thank you so much for coming to these workshops. I know they're very dense and fast-paced, but there's maybe a couple more GDG events this semester, so stay tuned. There won't be one next week because I'm tired and we have a game jam this weekend. So thank you so much. I hope you learned something. I know they're fast-paced, but that's why I recorded them. So yes, thank you. And that's all from me.